This week's programming tips video is focusing on mutation. So, mutation was introduced earlier this week, and by itself, it's not that hard to understand. But the problem is when you combine it with some other features, we'll see that you can get some pretty crazy code that is very difficult to understand. So we'll look at a few of these examples and see what the issues are, and introduce a mental tool to help us understand our programs. So for our first example, we're actually not going to be using mutation, just assignment. But we will be introducing our tool for understanding examples like this. Okay, so we have a series of assignments here. And the way we'll think of this is that first A gets assigned to something, okay, that contains 1. Okay. Then similarly, the next step is we do exactly the same sort of thing. We create same kind of thing that contains 2. Okay. Now next we do the same sort of operation here. We assign C to something. Well, this is a different kind of thing, so I'll make a different kind of box. Okay. And it contains 4, 5, and 6. And for D, well, looks exactly the same here. Another one of these boxes for a list that contains 4, 5, and 6. Now we assign E equals C. So we create our variable E here. Well, we're going to link it to exactly the same thing that C has, exactly the same value. So we see a distinction here that C and E have exactly the same value. They point to exactly the same box, whereas D points to a different box that just happens to look the same. That's an important distinction that we're going to explore more. So in this example, we'll now combine mutation with assignment. Okay, so we start off similar to the previous example here, that A is assigned to the list 4, 5, 6. So we put these items in some box, some object here. And then B, well, it looks just the same. It's another list, a separate list, consisting of 4, 5, 6. And then A1 gets 20. Okay, this is not assignment, this is mutation. We're changing A. Okay, and specifically the first element of A. And remember that we start counting with 0. So A1 here is replacing that, and we put a 20 there. Okay. Let's contrast that with what's going on down here with C and D. Okay. So C gets the list 2, 9, 0. And then here D is assigned to C. So what does that mean? D gets exactly the same value as C. So we're going to share that same thing, that same object that's containing the list. Okay. And then we're going to change C2. Okay. And once again, we start counting at 0. So C2 is over here, this last element. I'm going to cross that out and put a 10 here. But notice the big difference here. By changing C, we're also changing D because they're the same object. We've mutated both of them at the same time. Whereas with A and B, B happens to look the same as A initially, but then we change A, which doesn't change B, okay, because they're different objects that happen to look alike. Okay. Now, in terms of terminology, we say that C and D are aliased. They're the same thing. They're just different names for the same thing. Here's some code that comes directly from the previous example. The first two parts, using A, B, C, and D, are from the previous, and E and F are a similar example. Okay, what I'd like you to do is just pause this video and see if you can figure out what's going to be printed before you actually run it. Then start the video and I'll run it and we'll see if you were right. Okay, so running it here. As we saw in the previous example here, when we have A and B that start out, that they just happen to look alike, we mutate A, that leaves B unaffected. Whereas if we start out with C and D, and they actually are the same thing, and we mutate one, then we mutate the other. Okay, actually, as a side note, this is a good way to figure out whether two things are actually aliased. Try mutating one, see if the other is affected. Okay, then the third example here is really just an example of how can you make sure that you're not aliasing things. Okay, well, when you do an assignment, you can make a copy. There's many ways of copying a list, but one simple one is right here. You can simply use the list constructor. Okay, F equals list of E. And since then F just happens to look like E, it's a copy. When you mutate one, you don't mutate the other. For this example, let's see how mutation interacts with global variables and the global keyword. So here we have a couple functions, one of which is supposed to change part of a global variable to be the input, and then this other function which is supposed to change the entire global variable to be the input. And we call each of them. Okay. So once again, pause the video, see if you know what this is going to do before we continue and run the code. All right, so running this, okay. So the first function does what we wanted. It modifies, it mutates the global variable, okay, as we can see, the printout. And in the second one here, well, it did not change the global variable. Okay, well, what's the problem? As we have seen, we actually need the global keyword here. Okay, once we do that, the second example works. But notice that we did not need the global keyword in the first function where we're only using mutation. You only need the global keyword when you are assigning to a global variable. So next we're going to introduce a new type called tuples. They're just like lists except they're not mutable. Okay, we're going to look at a few examples, then I'll come back at the end to explain why would we ever want tuples if they're more restrictive than lists anyway. So here is a list. We can print square brackets and then some elements such as 4, 5, 6. And here is a tuple. A tuple is just the same except with parentheses instead of square brackets. Run that. They print out differently. Okay. Can you see that they're actually different things by I can print out what are the types of these. Okay. Introducing this function type, by the way. Okay, and you can see this first thing with the square brackets is a list. The second thing with the parentheses is a tuple, and that's how tuple is spelled. And now to illustrate the real difference between lists and tuples, here we create a list and we mutate it, print it out. We create a tuple, we mutate it, we print it out. Okay, so it printed out the mutated list, and then it gives us an error saying that tuples don't support mutation. As I said, the difference between them are lists are mutable, tuples are immutable. They cannot be mutated. You might think that the immutability of tuples is there just to annoy you, but really there can be a benefit. Sometimes you want to make sure that your data is not changed. So you can protect your data by putting it into a tuple as opposed to a list, which can be changed. Okay. This is especially important if you're working in a big project where you want to protect your data from somebody else accidentally changing it.